Now, most of the parts we're going to be using on this chassis are actually from Mid-America. We've got some Mid-America rear axle bushes. We've got Mid-America axle. We've got Mid-America pin tubes or floating pin tubes, a Mid-America guide nut that looks very much like the JK version. We've got some guide washers. The guide is actually a Red Fox guide, and it's one of the newest, longer versions. And the braids in there are SCB super thins, but I'll probably mention them later. The little tags that we're going to solder lead wire to, they're actually Mid-America too. They're modified, as most things are on slot cars these days. But we're going to start by setting up the back axle, getting these bushes in place. So in order to help me get the back axle set up and get it the same height both sides, I've got these little jig blocks here with a 332 hole down the middle, and the hole is spaced, different spacing from each side of the block. And you can see the spacing on these. So I've got a pair of these blocks, and I'm going to put one each side of the axle, obviously the same way round. And then that gives me the right spacing for the axle, depending on the type of gearing and track clearance rules, etc., that you need on the chassis. Now, because I'm building this for UK racing and potentially racing abroad as well, I'm going to be using the lowest axle setting. Now, this 0.295 gives me pretty much bang on 8.6 millimeters from the bottom of the chassis to the top of the axle when the axle's in place. It gives me a fraction more actually, but not much. And that's the rules for ISRA, which is 8.6 millimeters from the top of the axle to the bottom of the chassis. So these jig blocks are ideal for that. What also makes them quite good is they're also quite long, so they're very stable, and they're quite heavy, so they don't move when you're soldering as well. Some jig blocks I've come across are very narrow, they're not very stable, they're easy to move. They're quite lightweight, and when they're lightweight, even when the solder takes, they tend to pull the jig blocks a bit out of place. So these jig blocks are really good. And I did mention these in a previous video, and I ran out straight away. So I've had some more made, so I've got a good stock of these jig blocks now, if anybody is interested in them. But I use them all the time. I think they're great. I also have 2 millimeter versions that have got slightly different spacings as well, if you wanted to use 2 millimeter axles in your cars. Now, because I'm going to be soldering things to this chassis, and this chassis is plated, I don't always 100% trust the plating on the chassis. You can see it's very thin, and it is plated very nicely. There's no sort of bubbly bits or nasty bits on the plating. But whenever I solder to the chassis, I prefer to solder to the base metal rather than soldering to the plating. So I'm just going to take a little grinding wheel and grind off some of the plating around the holes where I'm going to solder. So there you can see I've just ground away that plating around the hole where I'm going to be soldering the bushes. You can still see the copper plating underneath there and that side there. And I've also done round the inside as well, just so the solder can take and I get a really nice solder joint. Now, some of you might say, oh, it's not necessary. Well, I have had in the past, I've had plating come off of chassis and things like the bushes have fallen out, motor's fallen out, and the plating's still stuck to the motor, but obviously the plating isn't stuck to the chassis. So because I've been bitten by that failure in the past, I don't want that failure again. So I always tend to get rid of the plating from wherever I'm going to solder first of all, and then I know I'm not going to have that problem. I'll probably do the same. It comes with a little motor brace, and when I solder the motor in, I'll do the same. Wherever I solder the motor, I'll get rid of the plating, and wherever I solder the brace, I'm going to get rid of the plating as well, so that they both solder directly to the base metal of the chassis. So I'll just show you a little close-up of these bushings. That's what they are. They're big shoulder 332 axle adjustable bushings, mid 554. So here they are. you can see that they've actually been turned down on this piece so that they've got a sort of big shoulder on them to solder on the outside to make a nice solder joint, but the diameter of them, or the external diameter of the part that goes into the pillar block of the chassis, is turned right down, so you can actually set whatever axle height you want. You're not constrained by the holes that are already in the chassis. Now, when soldering chassis and back axles in bushes into your chassis, some people have a chassis jig which has lots of little holes in it, so you can put little pegs in it and you can pin the guide tab where it is, you can clamp the chassis down, you can set different wheel bases with where you put the pins in the back of the chassis. I don't use one of those because I don't build that many total scratch built chassis. If you're bending them out of wire and brass and making your own, then yes, I'd say one of those will be definitely worth getting. But because I only generally just build either pre-cut chassis or production chassis like this one, I don't feel that it's been necessary for me to purchase one of those. But what you do need to make sure is that you get the back axle obviously, you know, perfectly perpendicular to the center line of the chassis. And some people you might even use some graph paper underneath, is a good indication of getting your back axle nice and straight. Some people might draw lines on a piece of paper and use that underneath. I'll show you my method, or how I check anyway, how I check the axle. But I generally do mine by eye, and it works out pretty close, to be fair. I've got good eyes. So I've got this set up with my 2 jig blocks. I've got my axle through the middle. I've got my 2 bushes. I've just put a little spacer by this one because this is the one I'm going to solder first. So I put a little spacer there. I'm going to put a little bit of oil on the axle on both sides like that, and that side as well, just to make sure that when I'm soldering that no solder runs actually onto the axle and solders it together, which I don't want. So I'm going to put a small blob of flux, and I'm going to be using, don't know whether you can read it here, it's actually some Lucky Bob's flux. I'll hold it that way for you. I like that, it's really good acid flux. And I use one of these little brushes here to apply my flux. They are available on Amazon. I'll put a link in the description of where you can get these from. They're really good because you can just apply little tiny bits of flux at a time to wherever you're soldering. So I've dipped it in the flux, and I'm going to apply a little bit of flux around the bushing like that, around the inside. Not too much to start with, because I'm just going to tack it in place until I'm happy that I've got everything right. So take my soldering iron, put a little bit of solder on the end of the iron. I'm just going to hold everything if I'm happy that I've lined it up, and I'm just going to tack it on a little bit of solder until it melts, just like that. And I've just tacked that bushing in place. I'm going to do the same with the other one. So I'm going to tack the other one in place. Just move that block away. A little bit of flux. Bit of solder on the end of the iron. And just tack it in place like that. So now neither one moves. The blocks are heavy enough to hold the axle down. I just needed to hold the chassis just in case I'd moved it with the iron when I touched it. And then I'm going to take the blocks off. Just check my axle moves smoothly. Yes, it does. It's not binding up. And I'm just going to double check and see how good my distance is on my axle. So you don't even need the calipers on because you're only doing a comparison here. But I push the axle out that way and I bring the calipers in. And I just sort of hold them pretty straight and just see how that matches on that side of the chassis and how that matches on that side of the chassis. So you can see I'm a fraction shorter on this side of the chassis because it passes a little bit further up that bar there than it does on that side. So just a fraction shorter. Double check. Yep. So I either need to go a fraction shorter on that side or a fraction longer on this side. But I'm probably within 0.1 of a mil I don't think it's any different than that. But as I'm a perfectionist, I'm just going to tweak it a fraction to improve that. So that's that side done. Now it's always worth reflowing the other side, because if you've moved the axle slightly, you still want the bushes aligned properly. So it's always worth reflowing the other side. Even though I'm not moving it, I'm just going to reflow it just to make sure it all lines up nicely on that side as well. Just double check. Yes, my axle moves nicely. So I'll do my final check. So I'll put that on there. I'll have to hold it upright and you can see. So if I bring it in to about that point there where it changes direction, and just close my calipers up a little bit like that against the axle so it gets tight there. And same the other side, it gets tight about there. And I'm very happy that I've got that axle to be perfectly right compared to the front of the chassis. So the next thing is just to flow a little bit more solder around those bushes and finish them off. I'm obviously not going to put so much heat on them that I melt the solder that I've already got there, because then I'll lose my alignment. But I'm going to put a little bit more flux around the inside there. A little bit more oil on the axle just to make sure I definitely don't solder that up by accident. And then we'll flow a bit more solder around that bushing. And there we go, axle moves freely still. I'm going to give this a little bit of a scrub and a clean up, and then I'll show you the result. So there we have it, soldered in axle bushes. Now the key thing is, has the solder flowed all the way around the axle bush? Well, yes it has there, and yes it has there. You can see it's flowed all the way around the bush, so that's held in nicely. I haven't put, obviously it hasn't quite filled the hole on this side here, but as it's already flowed all the way around the bush, then that's good enough. All I'll be doing now is probably just adding extra weight by putting more and more and more solder onto these bushes to fill the hole, which I don't need to do, as long as they're soldered all the way around. Now, when I said I was going to go away and give it a scrub, basically that's all I did. I took a toothbrush, I took some washing up liquid and gave it a good scrub. That gets rid of any of the acid flux that was on there and make sure that nothing is going to rust. Not that these chassis should rust with their plating, but just in case, I like to keep everything clean. It does get rid of all the flux that also comes out of the electrical solder, 60/40 solder that I normally use. So what axle height does that give me? Well, let's have a measure from the bottom of the chassis to the top of the axle, getting that sitting right there. 8.66 on that side. Flip it over. Let's measure this side. 8.65. It's a bit tight. 8.65. So that's within 1/100th of a millimetre from side to side, but that could very well just be the way the chassis is bent or the way I'm slightly holding my calipers. But I'm very happy within 1/100th of a millimetre each side. Now, as I've got a lot of American viewers, I'm going to convert that just to see 0.341 of an inch. And sorry, calipers have just started flashing, so that means my battery's starting to run out. But you can see what I mean from now. But remember, that's not a height from the centre of the axle to the bottom. It's from the top of the axle to the bottom. And as it's a 332 axle, it's approximately 2.37 millimetres in diameter, not 2.38, which is probably more of a true 332 millimetre axle. 2.37 tend to be the a lot of slot car axles, or 2.365 millimetres, depending on which versions you're using. So I'll put the little calculations on the screen now so you can work out what minimum tyre size that would be for zero clearance. So next up, we're going to fit these floating pin tubes, and they're really cool. Again, these are from Mid-America. You can see that they've got this little collar here and the long tube itself and two of these little O-rings, and I'll show you how they go together and how they fit onto the chassis. So the small O-ring, the very thin O-ring, slides straight onto your pin tube like that. And this is the thicker version of the O-ring. So the pin tube is then going to go through the hole in the chassis. The thicker O-ring is going to push on the back. And then finally, your little collar goes on the back of that and you solder that together. Now the beauty of these is with this extra O-ring and that O-ring there, it spaces them nicely onto your chassis. And it also, this thicker O-ring, stops any flux or solder from running down into the hole of the chassis and accidentally soldering up your floating pin tube. Now, these pin tubes, they do go into the chassis a little bit. If I hold it with a pair of tweezers like this, they do go in, but they don't actually float much. They wobble a little bit, but they don't actually float in the hole. They're a reasonably snug fit actually in the hole itself. Now, I'm wondering whether that's just because it's got some burrs around the edge of the hole that need cleaning off, that would just make these pin tubes float that little bit better in the holes of the chassis. So I'm going to use a tiny diamond bit in my trusty Proxon, and I'm just going to get rid of any burrs in these holes to hopefully make the floating pin tubes float nicely. So there we are. I've cleaned the burrs off from around the hole, and you should just be able to see now that there is a little bit of movement in that pin tube and how it floats around in that hole. Not a lot. Maybe I could have done with a little bit more, but I'm not going to open the hole up any bigger because that can be shunned upon in some rule sets, and people don't like you messing around with a base chassis too much. So that's basically the size of the hole, and they do fit and they do float once you've cleaned the burrs off. So you can see how that extra little O-ring helps the floating pin tube sit nice and level or nice and flush with the outside of the chassis rather than being in too far. I suppose you could have put a bigger collar on the outside when they were made, but the O-ring just adds that little bit of dampening, so it's not horrible and rattly. It just damps the pin tube a little bit and makes a nicer movement. So I've pushed the pin tube into the chassis and I've got the larger, thicker O-ring on the back. And you can see how I've just set it up just so there is a tiny gap between the O-ring and the chassis. That just allows the pin tube just that little bit more float. And I'm going to very carefully solder the collar in place, and then I'm going to do all the other pin tubes. So I'm going to put a tiny bit of oil, again, just on the back of that mount, just so it runs down, just to make sure that if solder does run past the O-ring, it's not going to solder the whole thing together. It shouldn't. I've done quite a few of these now and not had any problems, but I'm just trying to suggest things to you in case you put a bit too much solder on or hold the solder there for too long. So I'm going to put a little bit of flux around the collar, tiny bit of solder on the soldering iron. You do not need a lot of solder to do these. And there you have it before I've cleaned anything up. You can see that the solder has taken all the way around and the pin tube is still nice and floaty. The solder hasn't gone past the O-ring, and that's a nice job. I'm going to do all the other three now.
12 seconds later.
So there we have it. Back after again another little scrub. You can see that they are quite floaty now. There we go. And that's about the level of floatiness you want to achieve on your floating pin tubes. Floaty, floaty. Well, now that we're flat, we've got the bushes in, we know the chassis is going to sit nicely. We've also got our floaty, floaty pin tubes in. It's time for the finishing touches now to install the guide and look at how we go about putting the motor in.